So, I mean, we spent quite a bit of time already on modulo 2 division, but some key facts. First of all, that whatever divisor you select, you get a CRC which is 1 bit less. If you select a 33-bit divisor, you get a 32-bit CRC. If you select a 13-bit divisor, you get a 12-bit CRC. Okay? If you want to get an 8-bit CRC, what is the size of the divisor? 9-bit. And all of these are used, by the way. There are some protocols that use 8-bit CRC. There are some protocols that use 6-bit CRC. There are some protocols that use 12-bit CRC. There are some protocols that use 16-bit CRC and obviously 32-bit CRC. So your divisor has to be 1 bit more than the CRC length. Second fact is that whatever divisor you select, whatever number of CRC bits you want, you have to add that many number of bits at the end before you divide. So if I give you a message, you should remember to add the digits zeros. If you don't add, you will get the wrong answer. Alright? So if I give you this divisor and this message, first thing you say is, okay, this is 6 bits, I have to put 5 zeros there. Once you get the 5 zeros, then you start dividing step by step by step by step. When you have nothing more to borrow, you stop. Alright? So you can count how many steps there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can count how many bits there are. Basically, that will be related to these two numbers, because this will be, let's see, 1, 2, 3, plus 3, 6, 10. There are 10 bits in the message. Okay, so you can check that you finished all the bits and didn't skip any error, made any error. Okay, after you've done this, then you can do the same thing at the receiver. At the receiver, you get this number. The message comes back with the CRC filled in. Alright, now the receiver does the division and it should get a remainder 0. This is similar to the check digit method. In the check digit method, the receiver simply divides and makes sure that it is divisible by 9. If it is divisible by 9, it is happy. Similarly here, it is divisible by that number and therefore it is happy. Okay? Alright? So you should be able to do both. First get a CRC and then check it that it is correctly done. Alright. So that's the end of that. And so 4 things we learned, 3 things we learned. First thing is that the parity bit can detect 1 error. If you have more than parity bit, then you can correct some errors. So 1 bit parity cannot correct 1 error. It can just detect 1 bit error. And then we learned how to do multiple by longitudinal and the vertical and horizontal parities. We can do multi-bit and you can do actually 1 bit correction. And then for error detection, we can use a prime number. Here, when we talk about the decimal numbers, we talk about the prime numbers, and they provide a good error detection. However, we are not talking about the decimal numbers, we are talking about the binary numbers, and for that we use CRC. Now, another fact about CRC is, and we are really just touching the tip of the iceberg here, is that it is very easy to do in the hardware. It's trivial to do in hardware, it is difficult to do in software, but it's trivial circuit that can do CRC. So that's why when you have high speed things like Ethernet or anything which runs at gigabit and multi-gigabit, they use CRC and not the checksum. Checksum is software, CRC is hardware. Right? It is very difficult to do that. Long division looks so long, how would you do this 1500 bytes times 8 bits, like, I don't know, 120,000 bits or something, 120 some bits, 12,000 bits. Just too much to do like step by step. But in hardware, it is done just like that. Again, I cannot explain all that here because we have not really gone through the whole thing. But in some classes, we go through the whole hardware implementation as well. Alright, so the homework 5A. Homework 5A. Homework 5A says find the CRC of this message using a generator. So this generator is the same thing as a divisor. Okay? So this is the divisor, this is the message, and you have to show the long division basically. So you cannot just write the answer and say done.
So you have 3 zeros.
You will add 3 zeros and then you will divide, find when to end.
Can you do it on the board?
No. I already did one long one.
Not on the board you did.
No. So but why do I need to do it on the board? See, if this is something that you need to do, first of all, there's only so much we can do in the class. You need to do something and say, if there is a problem with this one, then I can do it. But it is the same thing. Yeah, in the exam, this problem will not be there. Here is one more thing. Examination, in the exam, I would probably give, obviously CRC is there, okay? I'm telling you, CRC is there, but the numbers will be different. It would be not, I would be crazy to give you the same numbers and say, okay, give me the answer. Everybody will have their own cheat sheet.
Can you give us the answer to 5A?
Yeah, I can give you the answer to 5A. Okay.
The show all steps means check that it's a valid number.
It's very easy to check, right? If you don't get 0, like at the receiver side, then
Yeah, you can check it right there. Yeah, you can check it right there. I will show you the answer later on, though. Actually, right now I need to. I need to continue this. I will show you before the end of the class in 10 minutes, in 5 minutes. All right. Now, as before, make sure that you read these pages and you do these problems and this review exercise and all that. Okay, so very clear about what you need to read and how far you need to read. Then we move to Ethernet. Now the CRC is used in every protocol that we know of and is very general, so that is general. Now we go into Ethernet, and Ethernet, in Ethernet we will talk about actually many different things, and they don't make sense right now anyway, so let me just go on to the Ethernet. First thing Ethernet does is allows multiple access, allows multiple people to talk on one wire. And there are 2 ways to do multiple people to talk on one wire. One is that you do by time, so everybody has a time limit. You speak sometime, then number 2 speaks sometime, then number 3 speaks, and so on and so forth. This is called time division multiplexing, TDM. Second method is FDM, frequency division multiplexing. That is what is used on cell phones. Somebody is talking on frequency 1, somebody is talking on frequency 2, somebody is talking on frequency 3, and so on. Right? And these are not exclusive. You could do both. You could do time division and frequency division. Any question here, please? If there is hello? Is there a comment that?
we're still stuck on homework 5A. Like, could you, I know it's really annoying us to keep.
Yeah, no, I will go to 5A. I will tell you why I'm not doing it right now. I will go to answer 5A in a minute. Please hold on to that one. CSMS-CD. Yeah. Yeah, you could do both. For example, you could do time and frequency. That will be lots of squares here. So for this time, station 1, 2, 3, 4, 5, 8, and the next time, station 8, 9, 10, 11, 12, and so on and so forth. So you could do time and frequency division, and there are other methods of dividing. However, CSMS-CD is what we are doing in Ethernet, and so that was started by a protocol called Aloha at University of Hawaii. You know, in Hawaii, there was the first place where they started wireless networks, and when they started wireless networks, they developed a protocol which was called Aloha for, reason understand. Anybody who has been to Hawaii knows Aloha means hello. Okay, Aloha means hello. So this is a hello protocol. Basically, the protocol, the way it works is that you can speak anytime. And that's the hello protocol. Hello is basically you're in a party and you go and you walk up to any person and say hello. You don't need the introduction for that. You say hello, I am so and so. And so hello protocol means basically you speak whenever you want. All right? So that is called multiple access. The problem with that is that if you do math, you will figure out that only 18% of the nodes will succeed, others will collide. So if you go to a party, if everybody says hello at the same time, nobody will know who is saying to whom and what's going on. There will be a lot of collisions, right? So they said what we will do is we will do a slotted aloha. A slotted aloha means that we will put the time limits, and within that time limit whoever speaks, so we will have equally spaced time, and so in this slot some people will speak, in this slot some other people will speak, and so on and so forth. Okay? So that is slotted aloha. If you do that, the efficiency goes up by a factor of 2, and that becomes 37%. By the way, it is 1 upon 2e, and this is 1 upon e. Everybody knows what e is, right? The natural log base, whatever. So CSMA means carrier sense multiple access. So the next achievement, extension was that look, please don't speak. Before you speak, listen. Listen before you speak. That means sense the carrier. See if somebody else is speaking. If somebody else is speaking, don't speak. So that is called carrier sense multiple access, CSMA. CSMA means before you speak, you listen for a few microseconds. If nobody is speaking, then you can say hello, or you can send your message in this case. Right? Good. All right. You waited until I stopped, because if you spoke at the same time when I spoke, that would be called collision. And so that is the next step. The next step actually, that next step was P persistent. P persistent meant that if you find the metal idle, don't speak. If the medium is idle, you take some probability, take a random number P, and then you speak. So if everybody draw a different random number, there won't be any collision, only 1 or 2 people will get, whoever gets the smallest lower random number will wait actually for that long. So you have to kind of draw a random number, how long to wait. And so whoever gets the smallest number will speak up first. And then you don't speak for 1 unit of time and for probability 1 minus b. And the final thing was CSMA-CD. CSMA-CD means that while you are speaking, you listen. And that's what I do. Basically, while I'm speaking, I am actually watching if somebody is trying to speak, and if they speak, I stop. So that is called collision detection. CSMA-CD is carrier sense. Before I speak, I see if nobody is speaking. Multiple access is fine. Basically, that's how we are all trying to share this medium. And CD means if I hear anybody else speak during my transmission, I stop. And in fact, that person will do the same thing. They will stop. All right. So that is where we are. So I am going to stop the lecture at this time. The exam will cover all the way up to 5A, and this is like 515.